Everybody to RDA Plenary 26 Birds of a Feather session on autonomous agents at the gate. This is a session about accelerating data visitation and the affordances of data visitation in the context of AI systems. I'm pleased to be here with members of the AIDV working group and special guests. If we could advance the slide, that'd be awesome. Here's a brief overview of the agenda. And as I referred to here in the room, we're having a watch party at Research Data Alliance United States, and we're pleased to join you from Washington, D.C. We're here with the RDA US 2026 cohort fellows, and pleased to introduce many new people to the organization. So I hope we can have a big welcome all around the table. And we're looking forward to a demonstration from Import, from NIH, and then a number of speaker presentations. And as typical for RDA, we hope for a vigorous panel discussion and Q&A. If you could advance the slides, please. Next, we will be hearing, one more slide, please. We'll be hearing from all the members of RDA in this session. So I ask that you be aware the session is being recorded. Keep your mic muted if you're not the speaker. We love it if you keep your camera on so that speakers feel like they're talking to an audience, even though this is a virtual plenary. And we'll all give one another the benefit of respectful dialogue in accordance with the Research Data Alliance Code of Conduct. We'll have Q&A at the end of the demonstration, as well as at the end of the panel. And if you have any questions or comments along the way, please feel free to insert those in the chat. And in the collaborative notes, you can see a link to that via the Word doc link above in the chat. So open up that document, enter your name. Next slide, please. And we'll get ready to kick this session off, welcoming all new members, including our cohort here in Washington, D.C., and celebrating the 6 guiding principles that are the heart of the RDA community: openness, consensus, harmonization, a community-driven approach that's nonprofit and tech neutral, and celebrates the inclusivity of our global community. Next slide. Here's a brief overview of the Artificial Intelligence and Data Visitation Working Group's recommendations. The recommendations you see at the top of the screen are the working group's council-endorsed recommendations. And at the bottom of the screen, you see several supporting and other outputs that may be useful to you in your own implementations. I draw particular attention to the System Security Assessment Plan template that Nana Bharathi, one of our panelists, contributed to our data visitation language for ICFs and for IRB protocols that Xian Young and Patty Buendita had big contributions to, and to all the 260 some members of the AIDV who have worked hard to get these recommendations out to the RDA and broader communities. Next slide. So without further ado, I turn it over to Xian Young to introduce Sanchita.
Thank you, Natalie. You're right on time, so I tried to do the same. I'm very pleased to have Sangeeta Bhattacharya from Import. She's a bioinformatics project scientist at the University of California, San Francisco, with over 12 years of experience working on the NIH and NIAID-sponsored Import database. She currently serves as the scientific outreach program lead for Import. Her work focuses on integrating multi-omics data using systems biology, AI, and machine learning approaches to better understand disease outcomes. With that, I hand it over to Sangeeta.
Thanks, Dr. Kim, for the nice introduction. Hello, everyone. First of all, I would like to thank the organizers for inviting me, and it's a pleasure to be here. Today, I'll be focusing on how Import supports AI-enabled immunology research and enables automated agent-driven data access. So I'll start with a brief overview of Import and then walk through a short demo showing how an AI agent can query the database and retrieve relevant data sets. To begin, let me step back and look at the bigger picture. So over the past decade, there has been a growing trend towards data democratization, making scientific data more accessible, shareable, and reusable across the research community. But access alone is no longer enough. As the volume and complexity of the data continue to grow, researchers are increasingly challenged with finding, integrating, and effectively using the right data set. So this is where the AI augmented data retrieval becomes very important. Rather than relying solely on manual search and filtering, AI can help interpret user intent, navigate complex metadata, and surface the most relevant data more efficiently. So we have been seeing a shift from simply making the data available to make it truly usable. So platforms like Import are evolving with this shift, helping bridge the gap between the accessible data and actionable insights. So Import is a data repository designed to organize and share immunology research data. It structures data into standardized metadata categories, which makes the datasets easier to find, interpret, and reuse. This level of organization is essential not just for researchers, but also for enabling the computational and AI-driven approaches. It organizes the data, as you can see here, in a standardized format. We have a kind of a template where people can organize the data in. There are many templates here, and for data ingestion, and then the data curation then organizes the metadata, curate the data, and make it available to the research community. We promote FAIR principles. Import ecosystem have upload data which is more kind of for the data submitters. For shared data is for disseminating the data to public. And then we have some resources for detailed documentation, tutorials, and so on. So who shares the data? So Import includes data from major NIAID programs and large research consortia, primarily from NIAID and DATE, Division of Allergy, Immunology, and Transplantation. This creates a rich, diverse data ecosystem, and you can see a long list of data submitters and consortia submitting data to Import. How do we actually access this data, right? So we have around close to now becoming 1,400 shared studies across research data. The beauty is that we support multimodal data, and we have primarily a lot of data coming from vaccine response, immune response, and then transplantation, allergy, autoimmune disease. So a variety from different sources, which gives a breadth and volume both in terms of the data sets that are available here. On the left are the list of the types of the amino acids, the data that we have, and the list is even longer than this. So we have lots of data. Finding the data. So how do we actually access and use this data? So Import provides both a web-based data browser, as you can see a screenshot here, and multiple APIs like Shared Data API. We also support HappyFire, GA4GH, DIRS API. So these are some of these ways the data can be downloaded. And I want to stress that these APIs enable programmatic access and critical for automation and AI integration. So building on this, we are also preparing data specifically for AI use. So AI-ready data sets, what is AI-ready data set, right? So often people ask me that question. So basically AI-ready data sets are clean and processed data in the usable format that can power an AI application So highlighting that this reduces the pre-processing effort and facilitate the integration across studies. So this sets the stage for more advanced AI-driven workflow. And here is the list, like, how import is offering or have the primarily the features that we have for programmatic or AI agent compliance, which is like RESTful API, G4GH, which I just mentioned earlier. Standard vocabularies is very important, and very soon we'll also introduce the semantic search, MCP server integration, data provenance and lineage is very important, and that's why I can't stress enough on metadata, which helps you to track the provenance and go through like how this data was all processed and when the researchers were conducting the experiments, which includes protocols and so on. And of course, the AI-ready data formats takes you one step further. All right, so this was all about brief overview of import, and I would like to acknowledge the team. Without their support and also the funding support from NIAID, this wasn't possible. And quickly, I'll go to the demo as I promised. So I'll just step back and just give you a quick, like, what is agentic AI? So agentic AI allows systems to not just answer queries, but take actions, like finding and retrieving the data. And import structured metadata and API enables this direct interaction between AI agents and the repository. That's what we're gonna see in the demo. So here is like the interface, or I have in the demo I'm going to demonstrate is from Google Anti-Gravity. And so the query that, or the task that I've given to the AI agent is find the studies in import related to rheumatoid arthritis that include synovial tissue samples and provide a list of studies and download the associated data. For a moment, I'll just switch to the demo.
You have 3 minutes. You can have 2 more minutes.
Sure, thank you.
Thanks.
All right, so here is the demo. Just to start, this is this anti-gravity, which is free. The one I have used is the free version. And then I just gave the task to the AI agent, which is to find this rheumatoid arthritis studies. Let me start. Is it, should I zoom in or are we good here?
It's hard to see the letters, not very visible.
Yeah, so maybe I can just help here. I'm saying what we are looking for is finding the rheumatoid arthritis studies from the synovial fluid samples in import.
Maybe you can zoom in a little bit. I can make it a little bigger, possible.
Okay. How about now?
A little
So
better, yeah.
Yeah, on the left, you can see that the AI agent is doing the task, which is kind of opening the import website. And here is the import and shared interface. And so agent is using the browser, searching, going to the browser, doing the free text, which is on the right, searching for the way we humans do, which is, typing rheumatoid arthritis and synovial fluid. That's the sample type. And then it returns a number of studies, which is in a table format. So there are multiple windows. One is where the agent is reporting what it's looking for. And on the window on the right is the import interface. And once it finds the data, as you can see here, once it finds the data, let me go back a little bit. So you could see here, it found about 7 studies satisfying the query, which is the rheumatoid arthritis and synovial fluid samples. Once it's identified the studies, now I'm going to start again. It generates a script. So it generates the Python program, which the user can download and then run the script on the local machine. So there is this, and then let me go forward. And now I have started the terminal here, and this is more human in the loop because that's how I have set it up. I didn't want to do it end to end because I would like to make sure that it's pulling the right data sets. This was my first time, so I was looking at and making sure that it's pulling the data correctly. And then I downloaded the data on my local machine, all the data sets from those 7 studies. Okay, so I'll stop here and again, go further a little bit, which is that's the download part. And then move here. So other thing that I want to point out is that, sometimes I have gotten 4014 error. So 40404 error, when I get that, I try to kind of communicate with the agent and say, can you go through this, the code? And it does that. So you can see here that it goes to the website. And in a moment, you're going to see that it goes to the particular study, and Import has an extensive documentation on APIs. So the agents can crawl and go through the documentation and then correct the code by itself. And that's what is shown here, that it corrects the code, debugs and corrects the code, and then runs it again.
Sangeeta, I think we might have to wrap it up. And if people can watch it later, if we can wrap it up in less than a minute, that'd be great. Thank you.
Yep, that's pretty much towards the end where what we are seeing right now is the agent going through the API documentation, debugging the code, and then downloading the data sets. So I think I am pretty much done here. And happy to take questions.
Please enter your question in the chat. If there's any questions about Sangeeta's demo or import, that was a great talk and demonstration. Thank you so much.
We have one question here from DC.
Great.
Hi, it's a really cool tool. I love to see that. I have a question. You touched briefly on the data sets being AI ready, and you talked a little bit about that. I was curious if you could say any more. I've been interested, a lot of things that make data sets AI ready are the same things that we've been pushing for a year, making them findable, accessible, structured. What are some of the differences? Is there anything unique about making something AI ready that is very different than making it human accessible the way that we've been doing in the past with fair data? So again, there's a lot of overlap, but what are the unique differences?
So I would say the unique difference is since we are getting this data from the data submitters as is, so once we curate the data, which includes data preparation, data quality. I would emphasize on data quality. So we along with the AI-ready data sets, we provide data completeness, consistency, integrity, provenance, data documentation, which includes the metadata. Are there any missing data or any other caveats in the data? So basically give a snapshot of how these data sets look like, right? So, so basically there are 4 components, like how the data was prepared, right? Single aggregated null values, outliers, annotation, data standardization, data quality, documentation is very important. How all of this data was generated, data access, which is like how the formats those are available, because for AI applications, you need to know even the volume, like, how big is the data. So these are a lot of statistics involved that those kind of surface when you provide AI-ready data sets. It encompasses many different data about the data, I would say, in detail.
Thank you, Sangeeta. We have one more question here in DC.
Yes, I thought it was a fascinating application. My question has to do with the accuracy of the application and the reception of it. How was it received by the researchers, and also the accuracy of the output?
You mean the one that I demoed, right? So that's why human in the loop is very important. You can set it up in an auto mode. The way I had been interacting was more like human in the loop. Every step, the agent takes my permission to go to the next and the next, because that's helpful for me to follow at each step what the agent is returning, and also it's kind of a quality sanity check, that what I'm looking for, and that's getting that's the output that I would like to get, and is it the true one, or is it there's any any errors or any issues with the retrieval. So since I have started playing with agentic AI platforms, I felt like I need to go through the steps, following the steps carefully. But it can be in auto mode. I prefer to be having like human in the loop for now.
What,
One
Dad,
more in-person question from Penyan.
Hi. Hi, this is Peng Yishan from UIUC at RDA US cohort. I have a question for making the data AI ready. I mean, on one side, it's good to be used at this, like, for example, import, like this kind of platform. On the other side, what is the risk that you see that this AI ready data be overused or misused on the commercial driven AI platforms? And what could be the potential risk and mitigations, so we can tell the researchers that before they make AI ready, this is something that need to consider?
If the data provenance, data documentation, all of them is done correctly with all the information as much transparent you can be, that's good. I see more benefit than the risk could be. I mean, misuse is not in our control, but particularly I can speak for import AI-ready data sets. I don't see too much of risk here, because of this detailed documentation. It should be fairly straightforward if people know are familiar with machine learning and AI. We are just catering them the data sets. So from the other end, probably I can't speak for that.
okay.
We have a question from Manu.
Okay.
More an answer to your question. I think in terms of risk, right now, the way it's set up is when these data sets are to be downloaded, import is a registered access repository, which means you need to be registered within import to access. And so people need to go through a click-through license. So an AI agent, as of now, cannot just come in and get access to the data without having an account with an import, right? And that has to be provided by a human, which is why what Sanchita did was more human in the loop kind of a setting, because we don't want folks that cannot, subscribe to our license to get the data. Does that help?
Thank you,
Anu.
Anu.
Thank you, Xianyang.
Yeah, sorry. We have so many questions. We might have to move along. I'm going to take one question from the chat. Patty, go ahead and ask quickly, and then we'll move the rest of the question to the later panel discussion session along with it. Thanks.
Anu actually answered the question. And so I would say the only comment would be that I know that you have to create an account or login for import. And that could be any software developer in the world could create one. So I guess there has to be some guardrails now and vetting of the person that is connecting to import, because anybody could nowadays create an agent. It's quite easy. That's all.
Sorry, I was just switching the slide because thank you so much. We are running a little over time, so we are about to start our panel discussion with the 6 speakers. We have a very tight schedule. The purpose of this panel discussion is, as you know, as autonomous AI agents begin interacting directly with the data infrastructures, important questions emerge, such as how should AI agents interact with the data repositories and trusted research environments? Or how can repositories support secure data visitation and compute-to-data workflows? Or how do we address the gap between rapidly evolving AI capabilities and slow-moving governance and policy frameworks? And our discussion goal is to identify key gaps and challenges in agent-mediated data access and explore problems the community may need to address collectively and consider potential guidance, framework, or outputs for the RDA community. With that, I'm going to introduce our first speaker, Nana Bharathi. Nana Bharathi is a practitioner and researcher in AI, machine learning, and modeling with a strong focus on socio-technical systems and risk. He has over 20 years of experience across industry and academia. Based at the University of Technology, Sydney, he serves as a data science and AI manager, works with the Australian Research Data Commons, where he leads advanced analytics initiatives, particularly in healthcare and the People Research Data Commons. With that, I'll hand it over to Nana.
Thank you, Sonia.
Mm-hmm.
Yeah. So we all know about AI agents, and so they've come up to the gate. But these are systems that plan, reason, and use tools or execute with varying levels of autonomy. And they're already here. Adoption is accelerating. But what is a risk profile? Firstly, they act and access data, and they can decide, and they can chain and interact with one another. So these are certain circumstances or contexts that actually increase the risk many folds. We can roll to the next slide. Next slide.
Yeah, sorry.
Sorry. Yeah. So as we have seen, adoption hasn't been that significant a problem. It's everyone seems to be clicking and jumping on the board and so on. But the risk landscape, mainly because of their interactions, even in some very ordinary circumstances, and because of the act of chaining, it results in certain unforeseen risk or hazards in this case. Other one, because of the AI agent autonomy and capability. I don't want to go through every risk, but most of which the audience would be familiar with. But let me quickly point out something. One is understanding context. And so, for example, there could be a stable patient fallacy because the agent doesn't take the external circumstances into account. So this is an ordinary case. And it's an ordinary situation, but it doesn't take the full context into account that any AI system, if deployed without proper guardrails and governance, could encounter. Another one could be because of the autonomy, capability, and the chaining effect that could come in. For say in this case, say for example, an agent senses a drift in something, and as a consequence, it takes an action, and so it maybe it goes overboard, and so it could be because of the cascading effect, and or as we seen in the first case, because of the interaction of the normal circumstances, normal agent capabilities, but they snowball. The second one, or it could also be simple silent failures, such as a simple bias, or often, say, in the case of healthcare, a nurse fails to solve a double checking, which should have been caught in the next stage, but because it's handed over to an agent, it multiplies. Other one is a goal misalignment, and because of the autonomy, and maybe agent over optimizes something, and so on. But oftentimes we pose human oversight as a panacea. It doesn't always work. I mean, there are circumstances in which the human oversight might work, and it might work in the case where there is enough time to decision, and then and so on. But we also need to understand that when you start using AI, when you start using AI agents, for example, you are bringing them on board because they create more efficiency. And so you are putting the system in the hands of something because it's a better system. More sophisticated it becomes, more chance, and humans might actually yield their autonomy and agency to AI. Like the case of a self-driving car, while it's being trained with the driver on, actually hit and kill somebody. And it is because after hours and hours sitting at the wheel, the person who was monitoring actually drifted to doing something else, such as watching a video and video streaming and so on. It really happened in 2018. So when we think about AI agents, especially, and when they are capable of taking over cascades of human decisions or actions, and do not always expect the human to be able to step in and take control. There are circumstances it's possible. There are circumstances it is not possible. So you need to think about the whole system, and think about each of the tasks and how the tasks are chained, and also the way the human factors play in this role, to be able to determine whether the risk is going to, each of the individual hazards could propagate or not. Can we go to the next one? Thank you.
Sure.
Yeah.
I'm sorry.
Yeah. Yeah. There are toolbox of resources, but let me summarize at a very high level. that these governance and risk assessment should be proactive. And we need to take a more systems approach to see the whole systems and the parts, often one of the things that is used in risk analysis and risk systems risk is to have multiple layers of safeguards. So don't always rely on humans. Often it's better to monitor an AI system with another AI system as a first layer of failure, and have multiple layers of failures to be arrested by another automated system and so on. The human oftentimes is best suited to be on the loop than in the loop. And of course, we also know that monitoring should come with a kill switch, and overall, it takes a village to raise these AI and the agents. With that, I will stop here.
Thanks, Nana. Our next speaker is Lars Eklund. Lars Eklund holds a PhD in theoretical physical and inorganic chemistry and has a background in software development, compliance, and validation. For the past 8 years, he has worked with the National Bioinformatics of Sweden and the Swedish National Data Service, focusing on HPC, sensitive data support, information security, GDPR, and AI ethics and regulation. With that, I hand it over to Lars.
Thank you very much. Next slide, please.
Sorry.
That's fine. We can start on this slide. It's okay.
Oh, sorry. Sorry, it's
it's
my.
okay. No worry.
Yeah.
So I am going to continue on Nana's track a bit, talking about how the agents look in the EU space. Europe is, of course, a lot larger than just EU, and there are many interesting initiatives going around outside of the EU as well. The reason I wanted to bring up the EU example is, one, that's where I work, but also because I think it has an idea that we need to think about. Next slide. And that is that you need to have this tiered approach with the trust layer, the data spaces, and the infrastructures. Where we see today, please be on the other slide, please. What we see today is that there's a lot of difference in how the readiness is, where the infrastructures and the data spaces start to implement these different services and servers. But as they do that, it's important to remember that we need to have the legislative and regulatory space, as well as the ethical considerations in mind, especially as we see data spaces. They tend to be a consortium of different groups rather than just one organization. And in EU, that means that a lot of them actually are publishing on the open market just while using internally within a data space or within a organizational group, because they are not legal entities in themselves. And this means that they actually need to start thinking about how this affects the organizations outside themselves. And I'm going to ask for the next slide. I have put together a few. Sorry, back, please.
Oh, sorry. I clicked on the wrong thing.
So I collected a few useful links around how EU is thinking about these things. And the last link I have, which also I have put in the collaborative notes, is that the European Union and the has actually put together a single sort of site for getting to understand how the legislative parts interact with these services, and sort of one site to rule them all, and that is the AI Act Service Desk, which the European Council has put together, which I think is a fantastic intro to sort of look at when you start implementing these agents, because we're trying to rush ahead to keep up with the private initiatives, and sometimes we as communities need to take a step back and make sure that we think about the risks that Nana so pointedly presented before. Thank you. I will leave to the next speaker.
Thank you so much. I'm so sorry about the clicking the wrong thing. It's hard to do this and then monitor the chat. I have to rely on others to share the links and then answer questions. Please keep your question to the end. We'll address all the questions in the chat box later. Our next speaker is Patty Buendia. Patty Buendia is the Chief Data and Technology Officer at Lifetime Omics and a leader in healthcare and life sciences. She has over 10 years of experience designing AI and machine learning platforms, biomedical data systems, and cloud-native analytics solutions. Her work bridges AI strategy, clinical informatics, and production engineering across AWS and GCP. She has led cross-functional teams, secured over $5 million in federal funding, and advanced infectious diseases and cancer research through integrated bioinformatics and computation analysis. With that, floor is yours, Patty.
Thank you, Seung-Yeon. Yeah, so I represent the private industry, although we're only a small business, but we use agents every day in our work. We develop software, and I just wanted to introduce like the evolution of autonomous agents and make it clear that there are different types. For example, we do use a lot of semi-autonomous agents in our work. And for example, what the demo that Sanchita showed, we work with similar agents trying to find data, and they're very easy and very quick to develop, which I'm going to show in the next slide. And most importantly, as we use some of these tools, we're seeing that even in a year, they are becoming more highly autonomous. They're adding more features that allow them to just on a single prompt to just run many different tasks. And so human oversight and training the human is becoming more important. So next slide. So one of the things that we're working on, and we don't have a lot of time for this, but I did speak about this in a previous session that you're going to see in when you look at the video, is we have a software called Fairless. It's a platform that runs quality control on the data and visits the data to analyze the quality or help curate the data. And it also uses AI. So in a version 1, the AI was very constricted to only the metadata. And what you can see here is just also, I'm going to very quickly show you when you're developing or designing digital twins, a human needs to be involved, and that takes a lot of time, could be days, weeks. Then Fairless QC is our software that takes a few hours to create a data dictionary and abstract the data. And then we use agents. You see it in step 3, and it's just in seconds or maybe up to 3 minutes. It creates a whole design on how to build an actual software, which is then done in step number 4. Here, the human is a software developer, and the final goal is to actually be able to use this abstraction of the real data to protect the data. So use digital twins to protect the data, and then be able to analyze it, do deep analysis, research it. Then you can use an agent to actually generate reports, etc. So that's some of the work we're doing. Next slide. And this here we're just sharing a little bit of how the autonomous agents are evolving and what it means for the human who works on them. And the humans in these cases are usually software developers. These are the ones that work for us at Lifetime Omics, and in many collaborators that we have in other companies. They are advancing very quickly, as Lars said. And in the private industry, it's mind-boggling how much they can achieve in very little time. So we're very much on top of that. There is a lot of competition going on, a lot of fear of missing out on AI. And that's where I think also guardrails on the humans are necessary, given that the new abilities they gain by working with agents.
Thank you, Patty. Our next speaker is Ronit, but I don't know if she can join. She just texted me saying the alarm went off. She's in Israel, so she's there. Okay, awesome.
Yeah, I'm back. Thank you.
Okay,
so
great.
much.
I introduce you just a second. Dr. Ronit Purian holds a PhD in information systems and focuses on incorporating behavioral, social, and environmental perspectives into service design and evaluation. Her work explores openness in system design and responsibility in technology implementation. She has co-chaired a co-data test group on smart cities, participates in the RDA AI and data visitation working group, and actively collaborates with industry. With that, floor is yours, Ronit.
Thank you very much. So what I wanted to present is a brief overview of the very wide landscape of cyber security in the industry, the sector, the big money. So in general, we have the network security, firewalls, we're all familiar with. We have the identity security, authentications, permissions, and AI security. These are the known security tools. The new ones are the agentic solutions. And there is, it's always keep on changing. There is a new wave coming with OpenClaw, but we'll not talk about that, just about the regular agentic solutions. So the next slide presents a general, if we can move to the next slide, please. This is a general overview of what agentic AI solutions we have today for handling with data and securing data. So if you can look at the first group, we have platforms that aim to integrate AI agents, and we have AI agents with specific goals. And what we see in the market, in reality outside, is a lot of mergers and acquisitions and consolidating the solution, trying to make some logical platform that can deal with all threats all over. There are also agentic-specific risk management applications, such as prompt injection. Nana mentioned some of them, and tools that track code to detect vulnerabilities and governance. So we can call it code security, and there are plenty of examples for each domain here and subdomain. If we can move to the next slide, thank you. So on the market, we can see a consolidation of heavily fortified proprietary platforms. But on our side, the governance-driven ecosystem, we can see a lot of like the right things. We do all the right things, but it's very scattered, and it's very difficult to see the consolidation and to connect and do something useful with all these efforts. Can we go to the next slide, please? Thanks. So the main question is how to build and govern an ecosystem, considering the tension between the two perspectives, two completely different perspectives of market-driven consolidation and our governance-driven ecosystem, and make it work. I mean, I think that our duty, and yesterday we had session, and in the final remarks, someone was talking about duty, and I think that that's the real thing here. It's not just nice talking about ethically grounded principles, but we really need to disseminate these principles. And the next slide, and the last one, it's not, if we can go back to slide 18, which is the slide about the purpose of slide 18.
Which one?
18, the purpose of the panel discussion. So,
we have to go all the way up there.
so no problem.
I don't think we have time to do that.
Okay,
Sorry.
so just saying that for some of the challenges, we can collaborate with the industry and the maturity product.
She might have been frozen.
In the industry, about the slow-moving governments and policy frameworks. This is our duty to enhance both consolidations and put barriers where they are needed. And I think that these are really important questions that we should focus on. Once we have time left. And I think that also in the industry, they are really concerned about these questions. So we have.
Okay, thank you, Ronit. I think the internet connection was a little sketchy, but thank you so much for joining us despite of the situation there. Our next speaker is Francis. Francis Crawley is a philosopher with over 40 years of experience in research ethics, integrity, and digital governance. He's the executive director of the Good Clinical Practice Alliance Europe and SIDCR, and chair of the RDA Artificial Intelligence Data Visitation Working Group. Many of you will recognize Francis from his strong presence across the RDA plenaries, where he actively contributes to discussions on data, ethics, and policy. And as Francis often says, ethics may not be the most practical career choice, but it is certainly a lifelong vocation. And his principal goal in life is to stay married. With that, the floor is yours, Francis.
Thank you very much, Se-Young. Do you have slides here for me? Because I have another set, but if you have slides, let's go to the next one. Perfect. Thank you very much. And the very first thing I want to say, talking about ethics here, is really our thoughts and prayers are with Ronit and everyone in the Middle East and in the world who is suffering through war, aggression, and violence. So we hope you stay safe, Ronit, with your family and friends there. Okay, so I wanted to talk about two sets of principles that we're developing. One is called the envisaged principles, and the other is the pilot principles. They go together. And we have now already the FAIR principles for data. We have the CARE principles for indigenous data, and we have the trust principles for data repositories. However, as I think you've seen from what Nana said, what Ronit has said, what Lars has said, we also need to think about how we can build into AI principles. And so in these two sets of principles, the first set here, the envisaged principles, is intended to give sort of an ethical background and an ethical foundation to it. So we're working on a paper right now. The paper is extraordinarily long because it really goes into depth into the principles. But the principles are here in order for us to situate AI within science, within education, but even more importantly, within the broader society. So we really want, when we're considering AI, we want to consider not just the technology, not just the outputs, not just the tools that it brings to us, but also the way it impacts and affects people. So we have here the principles of ethics, norms, values, integrity, sovereignty, access, governance, and engagement. And these principles we have as kind of an overall framework in which we want to, let's say, understand the ethics, legal, and societal implications of AI. But in the next slide with the pilot principles.
Oops, sorry.
Oh yeah, we don't need all that. Thank you. Yeah. My apologies here.
Oh, here,
that's
here,
here.
yeah.
That's good here. Yeah. Thank you so much. Yeah. It's
Sure.
my fault. And the pilot principles here, what we want to see with the pilot principles is the integration of these 5 principles into AI technologies. So we want to integrate, in the first place, ethics. But I think we also know that we're going to have to integrate also policy and regulation. And Nana and Ronit and the others spoke about this as well. It's impossible for us to govern AI, and now when we're talking about AI agents, it's impossible for us to, let's say, have ethical frameworks that are outside the systems, regulatory frameworks, legal frameworks, outside the systems. Just as with regard to data, we have to build fair principles into the data sets themselves, into the data repositories themselves. We have to do it. Well, we have to build within AI technologies, and that's plural. We have to build within them the capacity to do this. And I'll just stop with one example. And I've said this before. A few years ago, when we were developing the AI Act here in Belgium, in Brussels, which is in Belgium, with the European Commission, we had a meeting at the Microsoft offices in the center of Brussels, which is actually in the center of the European district of Brussels, with people from the Commission, with members of Parliament, with members of the Council. It was a big deal, with members of all these big companies and so forth. And during that meeting, I said, it's impossible for us to build a law for artificial intelligence over a period of 5 years when the technology itself moves so quickly. It's impossible, we can say also from the AIDV working group, to set up conditions for ethics review with ethics committees or for informed consent when the technologies change faster than we can change our hard or soft laws. So we must come up with a creative solution in order to impregnate, in order to instill or embed, perhaps better said, the principles within what we're doing. And I think purpose, integrity, lawful, open, and tested are principles that can work, that can be embedded into AI structures. So that's everything and a few other things I made up along the way. Thank you very much, Se-Young and everybody.
Thank you so much, Francis. I know you can talk about it for an hour. It's hard for me to monitor the chat and then do this in a presentation mode. So if you could share the link to the full slides, I know you have a whole hour presentation or a video recording. That'd be great. Thank you. Next speaker is Louis Jacob Retanen. He has trouble with the internet, so I'm going to advance it for him. Louis is a planning officer in the strategy division of the Office for Strategy and Policy at the Philippine Department of National Defense. He's an alumnus of Zhejiang University and the University of the Philippines. With that, I'll hand it over to Louis. The floor is yours.
So thank you very much, Soyoung, for this for advancing the slides for me. So good day, colleagues. So this presentation examines agentic AI use cases in cognitive warfare. So there's pretty much a rave about cognitive warfare today, especially that NATO has called on some kind of research call on looking on the interconnection between agentic AI and cognitive warfare. So, but in order to start this presentation, I think it would be helpful to provide a definition of cognitive warfare, and the most primary or most authoritative definition so far of cognitive warfare is given by NATO. So cognitive warfare is the activities conducted in synchronization with other instruments of power to affect attitudes, behaviors by influencing, protecting, and or disrupting individual and group cognitions to gain an advantage. So to operationalize this, I frame cognitive warfare across three interconnected dimensions. So first, the informational, so which targets the information environment, so what data and narratives people are exposed to. Second, the psychographic aspect or approach, which targets attitudes, beliefs, and behavioral patterns. Then third, the neurobiological, which engages the material conditions of cognition itself. So attention, stress, and neurological responses. So these three are analytically distinct but causally linked. So information shapes psychology, psychology is grounded on neurobiology. So together, they provide a comprehensive framework for understanding how agentic AI can operate across full spectrum of human cognition. So next slide, please. So the next question is, so how does agentic AI become central to cognitive warfare across these three dimensions? So agentic AI is uniquely positioned because it can process and synthesize data across different levels of intimacy of human-computer interactions. So at the information level, the most external, it works on extrinsic data within the information environment. Then at the psychographic level, it leverages behavioral and preference data. And at the most intimate level, at the neurobiological level, it can increasingly engage with neural or even genomic data sets. So this multi-layered access enables a goal-directed approach. So that is the defining, I think, the defining characteristics of agentic AI. So goal-directed approach. So it can generate and optimize content at the information level, tailor persuasion strategies to specific audiences at the psychographic level, and even map and anticipate cognitive responses at the neurobiological level. So in effect, it does not just communicate, it adapts, learns, and intervenes across the full spectrum of cognition. So crucially, these capabilities are further amplified through data visitation. So with data visitation, agentic systems or agentic AIs will now have the autonomous access. I can autonomously access and traverse and interact with diverse data sets and environments. So as data visitation expands, so too does agentic AI's capacity to train, refine, and exercise. So it has an amplifying effect. So it can now exercise a varying degrees of autonomy. At scale, this transforms agentic AI into something more than a tool. It functions simultaneously as an autonomous research analyst, so behavioral psychologists, and cognitive scientists. So basically, by continuously learning, modeling, and acting within the cognitive domain. So next slide. So finally, when agentic AI is combined with data visitation, it can operate with significant autonomy. So that is the problem here. So shifting from task-based execution to truly goal-directed behavior. So if such AI systems are leveraged for cognitive warfare across the informational, psychographic, and neurobiological spectrum, they effectively become weaponized agentic AI. So in this form, they can be directed towards strategic disinformation, so creating narratives that really can destroy national cohesion. Then computational propaganda. So these are the targeted or customized propaganda campaigns. And even neuro and genomic levels intervention, because this could sound like a science fiction, but these are already being discussed in NATO conferences and also by scholars in the United States like Jonathan Moreno and James Giordano. So the implications are profound. So these capabilities threaten human autonomy at multiple levels. So at the informational level, the autonomy of choice. At the psychographic level, the autonomy of values. So our capability to freely believe in what we want. And at the neurobiological level, the autonomy of being itself. So taken together, this constitutes a fundamental challenge to the individual cognitive liberty. But there's a twist here. Yet there's a deeper paradox. So the very strong I that underpins cognitive liberty. So what is this strong I? The self as an autonomous and rational agent is precisely what is being leveraged by weaponized agentic AI. So to be exact, our desire and pursuit for autonomy is being used against us. So in other words, autonomy is becoming also the point of greatest vulnerability and primary threat in the emerging landscape of cognitive warfare today. So that is all for my presentation. Thank you very much.
Thank you so much. I'm gonna get out of this full presentation mode because it's hard for me to see everything. So I wasn't able to monitor the chat session, but there were some questions left over from Sangeeta session and also the other panel discussion. So I would like people to speak up, unmute themselves if possible, or we can read out loud. So whichever you prefer.
We had a question for Nana from Julian. Julian asks about human supervision. There must be years and years of feedback and experience from like airplane autopilots. And Nana replies, he often argues that AI safety should learn and borrow from other safety critical fields, such as nuclear, aerospace, and chemical processing. Nana, would you like to add some comments related to Julian's question?
Certainly. For the level of risk these fields have been handling, the safety risks have been fairly well contained. You might say whatever about chemical industry, pollution, etc., etc. But still, in terms of the risk that they're sitting on, they have been they're well managed, and the credit goes to a number of factors, and especially the way they identify risk and assess it and manage it, and also the culture surrounding that, how to handle that, and but we cannot just go directly borrow that. And but even though aerospace industry, as you say, so many controls and so on, but the aerospace industry is trained to monitor for that risk and take over. Pilots are meant to do just that, and even then they handle the critical aspects of, for example, aircraft operation in human mode. But having said that, generally, machines are safer and less error prone than human. It is mainly it is in the interface that is often a problem, and that is, could human step in and take over? Could human actually detect a risk that we already automated? Because it is too difficult for human or too fast for human, and so on. And could we become complacent over time? So these are some of the questions that need to be answered. The aircraft cockpit, for example, is a classic example of how a human-machine interaction is designed. Years of experience and so on, and very stable HCI and human-machine interaction. Thank you.
Follow-on question from Becky Grady. She asks about whether and what is different about what AI needs from data than people. Becky, I'll hand it over to you.
It's exactly the question I asked earlier. I appreciate hearing different responses of it because so many people are working on this area and see different things. So many, just to remind people of the question, so many of the things that AI needs from data, like structure and documentation, are the same as what humans need from fair data. But what are the differences that you have seen are most important to make data AI ready?
In terms, who would answer that?
Anybody from the panel that wants to add something.
Yeah, Francis has his hands up.
Becky, it's a good question, but I want to put it a different way, and then you can respond to that, or somebody else can respond. We have invested heavily in data curation. We've invested heavily in the curation of data sets and of data repositories. We have a whole industry, and I think almost a religion, built around fair data. I think that's all out the window now. That's all finished. And because all this data curation, all this data structuring can and is being done very easily by AI. And particularly, we will see this even more so in the data visitation area as well. So I think it's not a question of structuring data for AI. This is my view on it. It's more a question of how does AI structure our data? And one other point I want to suggest. In the chat, I mentioned that we were working on sentient AI papers. I think we are at the end of the age of data. I hope so. Because we don't need data in the traditional sense, or sentient AI won't rely on data. The way AI works today, machine AI, for the large part, I won't say for everything, but largely, is pure hallucination because it has no access to the world. It has only access to descriptions made about the world, descriptions that are often put into fair frameworks. But these fair has nothing to do with the quality or the reality of the data. It only has to do with data structuring. And again, we don't need that with AI. So I would say the question is not how should we structure data for AI, but how will AI structure our data, and how will we move beyond, or how will AI take us beyond data, which it certainly will. Those are my thoughts. Yeah.
May I add something to that? I think one thing I noticed is AI does not, I mean, it does a good job of, consuming content, but they mainly look for metadata. So when we say AI-ready data set, that means it's more structured data, and then more structured metadata that AI can consume. And that's how we typically describe AI-ready data. Because sometimes they won't read all the context. They just look at the metadata. So when you actually share a link, ask AI to interpret something, they often miss it because they only look at the metadata. So either you save it as a PDF and share it, or specifically ask to crawl or use a web tool or something like that. So I think that's another angle we can look into when we say AI ready data. I just shared another link about it. Like a fair data principles is more for the regular data set, but when we talk about AI models and stuff like that, there's another principle we have to keep in mind. So DOME is another one we often talk about. So I just shared the link if anybody's interested. With the interest of time, I know there are more questions, but we really have to kind of leave this discussion for another possibly 10 minutes. I'm sorry, we have such an ambitious agenda. We could have easily, convert each talk to a 1 hour talk. So we definitely have a follow-up webinars and discussions. So we will take a few more questions from online or in the chat room, and then we'll move to the next session.
We've got one more here in the room.
Sorry, can I just make a short comment?
Go for it, Lars.
So something I was thinking about, especially this concerns both the questions earlier to Nana about aerospace and also Becky's question here about structure. So what we need to remember is that the biggest difference between modern AI compared to older AI systems, because AI has been around for a very long time, is that it used to be mostly rule-based AI systems, which basically means we have a structure. We've said this is what you should do. This is how the algorithm should follow it. This falls very well into the aerospace space where you have a very rules-based context, and it's like, this is what you need to do. These are the exact steps to follow. What the difference is in modern AI is that we've introduced the probabilistic systems, right? So like machine learning, we've introduced these things. These are not systems that are based on rules or strict algorithms that follow from A to B. These are probabilistic systems. They look at statistics. This is basically statistical evaluation tools that solve different types of mathematical equations, specifically differential equations. As we do this, we have to remember that we are going from the precise to the imprecise. And we're doing this knowingly that the data that we have will not be the data, as Francis so pointed out, that this is not the data that we present is not the data that is actually consumed by the AI itself. So we have to remember this when we use these systems, that we are moving from certainty to uncertainty by design.
That's a great observation. We got one more question here in the room.
Hello, this is Diana McSpadden from Jefferson Lab, part of the cohort here. This is such a great segue to my question. And I'm thinking about this idea of cognitive surrender that humans are doing to these AI systems. And I think part of that is that, well, a component of that may be that we don't have a concept of uncertainty quantification from these systems, especially one that is maybe, I may be using jargon from my own discipline, but distance-aware uncertainty quantification, especially for out-of-distribution data. And especially in this multi-agent universe that we're moving into, do any of the panelists know of uncertainty quantification techniques for these multi-agent workflows that are out there? Because as you just pointed out, we are in this probabilistic uncertainty universe, and that may allow humans to calibrate a way to understand the responses they're getting from these AI systems.
Thanks. That's a great question. Lars, do you want to take the first stab at it?
Yeah, I don't actually know of any systems at the moment, so there might be others that know systems that are currently in place for that. I mean, beyond the maths that are part of the models themselves, and there are functions that they produce. But yeah, we have compounding errors, so it's going to be very difficult, I think. Does anyone else have a good idea?
Yeah, I will take a stab at that. Not just the uncertainty quantification. There's all, just start with the modern, the contemporary, the big AI versus AI ML or the expert systems. One of the differences, the previous ones were more humbly called narrow AI. They were meant for a specific purpose, as Lars pointed out. Okay, this one sets of rules, but even when the machine learning came on, they were handling one specific case, and then they failed if the context shifted away from that. If you put totally different type of data, it failed, and so they are evaluated, they failed, and they can be monitored. The modern AI is because of the interface, language interface, it has, and also the broad-based training, it has come to inhabit everything under the sun. So it's very difficult to quantify uncertainty on one hand because each context is different. Secondly, it is not the AI that needs uncertainty quantification. Of course, it can give that uncertainty estimate, but it's human who are interacting and interpreting it. We are not trained for that uncertainty. And our world and our mental models are different from just getting the number. Getting the number, and because it is a universal application, ubiquitous, how are an average person who is going to be interacting with this AI or in this, going to interpret this uncertainty? 23% uncertainty. What does it mean? And so only thing you can do is you can build the safeguards inside the AI. But if you are allowing everyone in every context to come into one generic AI, that itself is a big risk. And that is something I don't have answer to. Yeah, but uncertainty quantifications exist in many forms. But what can we do with that?
Thank you. I had to be time police, so sorry about that. Obviously, there are a lot of interest and questions around this topic. We could have a whole day symposium on this one. So we definitely have a follow-up webinars and discussions. So I will have to move on. We'll go to the next session. We'll take some polls, and then please join the group so that you can continue chiming in, and then attend follow-up webinars, and potentially creating a work group or interest group. So please do join our work group, AIDV work group, and we'll continue our conversation. So I'd like to move on to the next session. We'll take some session polls and then closing remarks. If you have a burning questions, please enter into the chat. We'll try to get to it if possible, or if not, we'll follow up with you after the session. Thank you. Natalie, you want to take the next slide? People can scan the QR code to take the session poll.
Everybody, please join the poll. ahaslides.com, capital E, 3, S like Sierra, 3, K like Kilo, E, 3, S, 3, K. Which of the topics addressed by today's panelists could we further best by work and research data alliance interest in working groups? We're really interested in your feedback on this, as evidenced by our many questions after the panel and the diversity of panel presentations. It's clear that we have a lot more conversations to pursue related to what we've encountered today that could take the form of future webinars, symposia, or other gatherings at future plenaries. We can throw together some BoFs. So please put your feelings in this poll to show us where to take the activities of these wonderful AIDV members next. I'll give it a couple minutes, minute maybe, and then we'll move on to the next one. I think Louise's presentation helps us look at human vulnerability to AI threats in a couple of different ways. One, in reference to the data about us that's increasingly available to AI. And secondly, what happens when you intersect that with data about our preferences and how that can be leveraged to change what we think, feel, do, where we exercise, what we eat, who we talk to. That informs what we know and where we take our bodies and what we do with them. And we can easily see how that can be manipulated. We also see from all the questions for Francis that when it comes to putting policy into practice, there's a lot of heavy lifting to be done there. And increasingly, the growing participation in the questions central to artificial intelligence and data visitation working group exposes to the channels that our colleagues are working in every day, like in the import demo and more. Let's move on to the next question. Which of your questions remained unanswered today that we should address in future work in meetings like today's? And here, go to town, we'll combine it with all of your questions in the chat, which I've pasted into the collaborative notes. And these can be the source of proposals for future symposia. They can be ways for you to come present the work of your lab group or your dissertation project. They can be ways for you to take your personal work and broaden it to global context through participation in RDA. Let's leave this up a moment or two since it requires typing, Xian Young, and then we'll turn it over to you.
All right. Thank you. Sorry. Do I need to? Okay, we're a little longer.
Francis comments in the chat that the purpose of this Birds of a Feather today is to discuss pathways forward that we looked at from the Ask Future RDA AIDV. Specifically, today we're presenting some of our ideas on agentic AI and hope to have everyone's input in developing a statement of work for an RDA working group or interest group on this topic or the others that are rising from today's questions and interests. Christina gives it to everyone's attention. There's a STM group having parallel conversations on this topic too. Christina asks, is there anyone from today's panel who could join tomorrow's session on data spaces? If you could message Christina directly in the chat or on Huva, you can DM on Huva.
Can we scroll down a little bit? I think we're getting a little more responses. I mean, scroll down, the more answers, to show the more answers. Yes, thank you. Or make it bigger.
I don't know if I can the way this share works. I'm doing my
It's
best
okay.
here.
Yeah. Well, we'll capture it in our collaborative note later on. So
thanks.
Thank
We
you.
appreciate all your participation today. We're near time with just a few minutes to go. I'm going to turn it back over to Xian Young, who will bring us home. Thanks, Xian. I'm going to stop my share.
Thank you. This was a fantastic session. So many discussion points, questions unanswered. So I hope you all enjoyed this session and learn from it, and then help us take it to the next step. So we are developing statement of work, and we're trying to form a work group, taking this to the next step. So please join AIDV. There will be some follow-up webinars and discussions. If you put your name in the collaborative note and also join our group, you'll stay informed and then join us in our next endeavor. So thank you so much for everyone. Sorry we didn't get to address all the questions you have, but please do know that we're going to have a follow-up questions and webinars to expand what we discussed today. So thank you so much for joining us, and we look forward to seeing you in our next session and further discussions. Thank you. And thank you all speakers and the participants. Thank you so much. It was a wonderful session. Thanks.
Thank you, Seong, Honit, Francis, everyone.
Thank you.
Thank you, AIDV panelists. From all of us here in DC, we say we'll see you later at the plenary. Thanks.
Thanks for joining us. Thanks for organizing this session. Thank you.
Thank you, Young.
Thank you. I will definitely have an expanded session for your agentic AI demo. So stay tuned for that.
No worries, no worries. Okay.
Thank you.